Asteroids are minor planets, especially those of the inner solar system. The larger ones have also been called planetoids. These terms have historically been applied to any astronomical object orbiting the Sun that did not show the disk of a planet and was not observed to have the characteristics of an active comet. As minor planets in the outer solar system were discovered and found to have volatile-based surfaces that resemble those of comets, they were often distinguished from asteroids of the asteroid belt. In this article, the term asteroid refers to the minor planets of the inner solar system, including those co-orbital with Jupiter. There are millions of asteroids, many thought to be the shattered remnants of planetesimals, bodies within the young Sun's solar nebula that never grew large enough to become planets. The large majority of known asteroids orbit in the asteroid belt between the orbits of Mars and Jupiter, or are co-orbital with Jupiter. However, other orbital families exist with significant populations, including the near-Earth asteroids. Individual asteroids are classified by their characteristic spectra, with the majority falling into three main groups: C-type, M-type, and S-type. These were named after and are generally identified with carbon-rich, metallic, and silicate compositions, respectively. The size of asteroids varies greatly, some reaching as much as 7 quintillion 6 quadrillion 100 trillion spadesuit 1,000 kilometers across. Asteroids are differentiated from comets and meteoroids. In the case of comets, the difference is one of composition. While asteroids are mainly composed of mineral and rock, comets are composed of dust and ice. In addition, asteroids formed closer to the Sun, preventing the development of the aforementioned cometary ice. The difference between asteroids and meteoroids is mainly one of size. Meteoroids have a diameter of less than 1 meter, whereas asteroids have a diameter of greater than 1 meter. Finally, meteoroids can be composed of either cometary or asteroidal materials. Only one asteroid, Vesta, which has a relatively reflective surface, is normally visible to the naked eye, and thus only in very dark skies when it is favorably positioned. Really small asteroids passing close to Earth may be visible to the naked eye for a short time. As of March 2016, the Minor Planet Center had data on more than 1.3 million objects in the inner and outer solar system, of which 750,000 had enough information to be given numbered designations. Discovery. The first asteroid to be discovered, Ceres, was found in 1801 by Giuseppe Piazzi, and was originally considered to be a new planet. This was followed by the discovery of other similar bodies, which, with the equipment of the time, appeared to be points of light, like stars, showing little or no planetary disk, though readily distinguishable from stars due to their apparent motions. This prompted the astronomer Sir William Herschel to propose the term asteroid, coined in Greek as sigma tau epsilon rho omicron epsilon iota delta eta sigma, or asteroids, meaning starlight, star-shaped, and derived from the ancient Greek sigma tau eta rho aster, star, planet. In the early second half of the 19th century, the terms asteroid and planet were still used interchangeably. Historical methods. Asteroid discovery methods have dramatically improved over the past 2 centuries. In the last years of the 18th century, Baron Franz Xaver von Zach organized a group of 24 astronomers to search the sky for the missing planet predicted at about 2.8 astronomical units from the Sun by the Titius-Bode law, partly because of the discovery by Sir William Herschel in 1781 of the planet Uranus at the distance predicted by the law. This task required that hand-drawn sky charts be prepared for all stars in the zodiacal band down to an agreed-upon limit of faintness. On subsequent nights, the sky would be charted again and any moving object would, hopefully, be spotted. The expected motion of the missing planet was about 30 seconds of arc per hour, readily discernible by observers. The first object, Ceres, was not discovered by a member of the group, but rather by accident in 1801 by Giuseppe Piazzi, director of the Observatory of Palermo in Sicily. He discovered a new star-like object in Taurus and followed the displacement of this object during several nights. Later that year, Carl Friedrich Gauss used these observations to calculate the orbit of this unknown object, which was found to be between the planets Mars and Jupiter. Piazzi named it after Ceres, the Roman goddess of agriculture. 3 other asteroids were discovered over the next few years, with Vesta found in 1807. After 8 more years of fruitless searches, most astronomers assumed that there were no more and abandoned any further searches. However, Carl Ludwig Henke persisted, and began searching for more asteroids in 1830. 15 years later, he found 5 Asteroids, the first new asteroid in 38 years. He also found 6 Hebe less than 2 years later. After this, other astronomers joined in the search, and at least 1 new asteroid was discovered every year after that. Notable asteroid hunters of this early era were J.R. Hind, Annibal de Gasparis, Robert Luther, H.M.S. Goldschmidt, Jean Jacques Ornac, James Ferguson, Norman Robert Pogson, E.W. Temple, J.C. Watson, C.H. F. Peters, A. Burley, J. Palliser, the Henry brothers, and Auguste Charlevoix. In 1891, Max Wolf pioneered the use of astrophotography to detect asteroids, which appeared as short streaks on long-exposure photographic plates. This dramatically increased the rate of detection compared with earlier visual methods. Wolf alone discovered 248 asteroids, beginning with 323 Brucia, whereas only slightly more than 300 had been discovered up to that point. It was known that there were many more, but most astronomers did not bother with them, calling them vermin of the skies, a phrase variously attributed to Edward Suess and Edmund Weiss. Even a century later, only a few thousand asteroids were identified, numbered and named. Manual methods of the 1900s and modern reporting. Until 1998, asteroids were discovered by a 4-step process. First, a region of the sky was photographed by a wide-field telescope, or astronograph. Pairs of photographs were taken, typically 1 hour apart. Multiple pairs could be taken over a series of days. Second, the 2 films or plates of the same region were viewed under a stereoscope. Anybody in orbit around the Sun would move slightly between the pair of films. Under the stereoscope, the image of the body would seem to float slightly above the background of stars. Third, once a moving body was identified, its location would be measured precisely using a digitizing microscope. The location would be measured relative to known star locations. These first 3 steps do not constitute asteroid discovery. The observer has only found an apparition, which gets a provisional designation, made up of the year of discovery, a letter representing the half-month of discovery, and finally a letter and a number indicating the discovery's sequential number. The last step of discovery is to send the locations and time of observations to the Minor Planet Center, where computer programs determine whether an apparition ties together earlier apparitions into a single orbit. If so, the object receives a catalog number, and the observer of the first apparition with a calculated orbit is declared the discoverer, and granted the honor of naming the object, subject to the approval of the International Astronomical Union. Computerized methods. There is increasing interest in identifying asteroids whose orbits cross Earth's, and that could, given enough time, collide with Earth. The three most important groups of near-Earth asteroids are the Apollos, Amors, and Atins. Various asteroid deflection strategies have been proposed as early as the 1960s. The near-Earth asteroid 433 Eros had been discovered as long ago as 1898, and the 1930s brought a flurry of similar objects. In order of discovery, these were 1221 Amor, 1862 Apollo, 2101 Adonis, and finally 69,230 Hermes, which approached within 0.005 astronomical units of Earth in 1937. Astronomers began to realize the possibilities of Earth impact. Two events in later decades increased the alarm: the increasing acceptance of Walter Alvarez's hypothesis that an impact event resulted in the Cretaceous-Paleogene extinction, and the 1994 observation of comet Shoemaker-Levy 9 crashing into Jupiter. The U.S. military also declassified the information that its military satellites built to detect nuclear explosions had detected hundreds of upper atmosphere impacts by objects ranging from 1 to 10 meters across. All these considerations helped spur the launch of highly efficient surveys that consist of charge-coupled device cameras and computers directly connected to telescopes. As of spring 2011, it was estimated that 89% to 96% of near-Earth asteroids 1 kilometer or larger in diameter had been discovered. A list of teams using such systems includes the Lincoln Near-Earth Asteroid Research Team, the Near-Earth Asteroid Tracking Team, Spacewatch, the Lowell Observatory Near-Earth Object Search Team, the Catalina Sky Survey, the Campo Imperator Near-Earth Object Survey Team, the Japanese Space Guard Association, the Asiago DLR Asteroid Survey. The Linear System alone has discovered 138,393 asteroids as of the 20th of September 2013. Among all the surveys, 4,711 near-Earth asteroids have been discovered, including over 600 more than 1 kilometer in diameter. Terminology: traditionally, small bodies orbiting the Sun were classified as comets, asteroids, or meteoroids, with anything smaller than 10 meters across being called a meteoroid. The term asteroid, from the Greek word for star-like, never had a formal definition, with the broader term minor planet being preferred by the International Astronomical Union. However, following the discovery of asteroids below 10 meters in size, Rubin and Grossman in a 2010 paper revised the previous definition of meteoroid to objects between 10 micrometers and 1 meter in size in order to maintain the distinction between asteroids and meteoroids. The smallest asteroids discovered are 2008 TS26 with H equals 33.2 and 2011 CQ1 with H equals 32.1, both with an estimated size of about 1 meter. In 2006, the term small solar system body was also introduced to cover both most minor planets and comets. Other languages prefer planetoid, and this term is occasionally used in English, especially for larger minor planets such as the dwarf planets, as well as an alternative for asteroids. Since they are not star-like, the word planetesimal has a similar meaning, but refers specifically to the small building blocks of the planets that existed when the solar system was forming. The term planetule was coined by the geologist William Daniel Conybeare to describe minor planets, but is not in common use. The three largest objects in the asteroid belt, Ceres, Pallas, and Vesta, grew to the stage of protoplanets. Ceres is a dwarf planet, the only one in the inner solar system. When found, asteroids were seen as a class of objects distinct from comets, and there was no unified term for the two until small solar system body was coined in 2006. The main difference between an asteroid and a comet is that a comet shows a coma due to sublimation of near-surface ices by solar radiation. A few objects have ended up being dual-listed because they were first classified as minor planets but later showed evidence of cometary activity. Conversely, some comets are eventually depleted of the surface volatile ices and become asteroid-like. A further distinction is that comets typically have more eccentric orbits than most asteroids. Most asteroids with notably eccentric orbits are probably dormant or extinct comets. For almost 2 centuries, from the discovery of Ceres in 1801 until the discovery of the first centaur, Chiron, in 1977, all known asteroids spent most of their time at or within the orbit of Jupiter, though a few such as Hidalgo ventured far beyond Jupiter for part of their orbit. When astronomers started finding more small bodies that permanently resided further out than Jupiter, now called centaurs, they numbered them among the traditional asteroids, though there was debate over whether they should be considered asteroids or as a new type of object. Then, when the first trans-Neptunian object, 1992 QB1, was discovered in 1992, and especially when large numbers of similar objects started turning up, new terms were invented to sidestep the issue. Kuiper belt object, trans-Neptunian object, scattered disk object, and so on. These inhabit the cold outer reaches of the Solar System where ices remain solid and comet-like bodies are not expected to exhibit much cometary activity. If centaurs or trans-Neptunian objects were to venture close to the Sun, the volatile ices would sublimate, and traditional approaches would classify them as comets and not asteroids. The innermost of these are the Kuiper belt objects, called objects, partly to avoid the need to classify them as asteroids or comets. They are thought to be predominantly comet-like in composition, though some may be more akin to asteroids. Furthermore, most do not have the highly eccentric orbits associated with comets, and the ones so far discovered are larger than traditional comet nuclei. Other recent observations, such as the analysis of the cometary dust collected by the Stardust probe, are increasingly blurring the distinction between comets and asteroids, suggesting a continuum between asteroids and comets, rather than a sharp dividing line. The minor planets beyond Jupiter's orbit are sometimes also called asteroids, especially in popular presentations. However, it is becoming increasingly common for the term asteroid to be restricted to minor planets of the inner solar system. Therefore, this article will restrict itself for the most part to the classical asteroids, objects of the asteroid belt, Jupiter Trojans, and near-Earth objects. When the IAU introduced the class Small Solar System bodies in 2006 to include most objects previously classified as minor planets and comets, they created the class of dwarf planets for the largest minor planets, those that have enough mass to have become ellipsoidal under their own gravity. According to the IAU, the term minor planet may still be used, but generally the term small solar system body will be preferred. Currently only the largest object in the asteroid belt, Ceres, at about 950 kilometers across, has been placed in the dwarf planet category. Formation. It is thought that planetesimals in the asteroid belt evolved much like the rest of the solar nebula until Jupiter neared its current mass, at which point excitation from orbital resonances with Jupiter ejected over 99% of planetesimals in the belt. Simulations and a discontinuity in spin rate and spectral properties suggest that asteroids larger than approximately 120 kilometers in diameter accreted during that early era, whereas smaller bodies are fragments from collisions between asteroids during or after the Jovian disruption, Ceres and Vesta grew large enough to melt and differentiate, with heavy metallic elements sinking to the core, leaving rocky minerals in the crust. In the NICE model, many Kuiper belt objects are captured in the outer asteroid belt, at distances greater than 2.6 astronomical units. Most were later ejected by Jupiter, but those that remained may be the D-type asteroids, and possibly include Ceres. Distribution within the Solar System. Various dynamical groups of asteroids have been discovered orbiting in the inner Solar System, their orbits perturbed by the gravity of other bodies in the Solar System and by the Yarkowski effect. Significant populations include asteroid belt. The majority of known asteroids orbit within the asteroid belt between the orbits of Mars and Jupiter, generally in relatively low eccentricity orbits. This belt is now estimated to contain between 1.1 and 1.9 million asteroids larger than 1 kilometer in diameter, and millions of smaller ones. These asteroids may be remnants of the protoplanetary disk, and in this region the accretion of planetesimals into planets during the formative period of the Solar System was prevented by large gravitational perturbations by Jupiter. Trojans. Trojans are populations that share an orbit with a larger planet or moon, but do not collide with it because they orbit in one of the two Lagrangian points of stability, L4 and L5, which lie 60 degrees ahead of and behind the larger body. The most significant population of Trojans are the Jupiter Trojans. Although fewer Jupiter Trojans have been discovered as of 2010, it is thought that they are as numerous as the asteroids in the asteroid belt. A couple of Trojans have also been found orbiting with Mars. Near-Earth asteroids. Near-Earth asteroids, or NEAs, are asteroids that have orbits that pass close to that of Earth. Asteroids that actually cross Earth's orbital path are known as Earth crosses.